Hello everyone, I welcome you all in this course Introduction to Sequence Stratigraphy, and we are discussing about the different types of systems tracts, and within that discussion in last couple of classes we have discussed about the transgressive systems tract. So, in our previous discussions on transgressive systems tract, we have tried to understand what are the major processes, what are the products that occur, that form across the basin. So, in this class we will try to discuss on that aspect in little bit more detail, and we will try to understand that with the help of certain simple diagrams to understand the distribution of the processes and the conditions that occur across the basin from continental side to the deep basinal part in terms of the processes and the products. So, already we know that during the TST, during a transgression, the sediments are transported landward during the fair weather, which results in the formation of a backstepping beach or an estuary. However, there can be variations. So, we can get formation of deltas, which may also form at the river mouth areas during this backstepping process. However, broadly estuary will form, and followed by that these sediments, majority of which are commonly trapped within this marginal marine area, other sediments may get further dispersed towards the seaward direction on the shelf area by some storm surges or tidal currents, which may form some shelfal macroforms in the form of sand seed bodies, sand ridge like structures, or sand ribbon or wedge like structures, and followed by that we get certain deposits in the deep basinal part in the form of some low density turbidites or high density debris flow or mud flow deposits. So, in a nutshell, this is the overall distribution pattern of sediments, sediment packages or depositional systems across the entire basin during a transgression. So, if I want to represent this in a simple sequence stratigraphic diagram, so from the shoreline area we can start from, say, this is the unconformity which is formed during the force regressive phase, which have been covered up by the normal regressive deposits, the normal regressive delta, which is forming the self edge delta, and finally what we are getting is the deposits in the deep basinal part in the form of some low density turbidites during the end of LST. So, this surface from here on to this is the maximum regressive surface, and this part is the unconformity surface. So, on this surface now the base level, which was here level 1, it is now rising up, say for example it is rising to level 2. In response to this base level rise, and the rate of sedimentation is less than the rate of base level rise, what we get over here in the fluvial part, we get fluvial aggradation and onlap, which may be transgressed by, which may be retrograded by the estuarine deposits which are forming over here. So, this part is the fluvial deposits commonly associated with fluvial onlap. This area, this is the estuary form. Broadly we are using the term estuary, but in the last class we have discussed that there can be variations in terms of formation of a delta in the retrograding system, a bayhead delta or an estuary. And this estuary may be further overlain by the coastal deposits, coastal sands or the beach deposits, which may further transgress in, further retrograde in. So, this is the scenario which is occurring in this area, in this part, and in the deeper part we can expect deposition of some deposits deposited over here, which we commonly call as the transgressive slope apron, transgressive slope apron, or also these are called as healing phase deposits, which are commonly very fine grained deposits initially, and that may be covered up by the backfilling canyon deposits formed by high density mud flow. And along with that we get deposition of the mud flow deposits and low density turbidites formed over here in the depressional part. So, this entire package will be covered up by a surface which is called as the maximum flooding surface, which may be traced over here and which may be traced over here as well. So, as discussed in our first class on this transgressive systems tract, we discussed over there that the packages of transgressive systems tract can be found in two different sectors, two different areas. One in the fluvial to coastal onlap, and second one the marine onlap, which is present over here. So, these are the dominant areas where we can expect deposition, formation of sedimentation packages, formation of the systems tract during a transgressive phase. The intermittent area, particularly for example this part, it is devoid of any deposit, and so we cannot get any transgressive package over here, and we cannot trace the maximum flooding surface over here. Now, this is the overall distribution of the sediment packages starting from fluvial to depressional part in the frame of sequence stratigraphy, in the frame of sequence stratigraphic elements. But if I want to understand this in little bit more detail, then we have to divide this entire distribution pattern of processes and products into two halves. First, the early phase of the TST, early phase of the transgression, and second, the late phase of the transgression, the late TST package. So, let us see what happens during the early phase of TST. So, when we are talking about the early phase of TST, so we are looking at, say for example, if this is the base level curve, if this is the entire transgressive phase, then we are looking at this much of area, this much of part of the transgressive phase, which is the early phase of transgression. So, during this early phase of transgression, what are the possible changes, what are the possible conditions? So, if I look into the fluvial part, say if I want to draw a simple basin diagram, so in the fluvial part, what we expect, the fluvial system is now aggrading. So, definitely there will be a meandering river system that will be formed, and that meandering river system will be ending up at the shoreline with the formation of an estuary. Maybe some bayhead delta may form over here in this area, but dominantly it will be an estuary. So, this is the strand plane, this is the strand line, and there we can expect formation of barrier beaches. These barrier beaches are actually the retrograding barrier beaches. The earlier surface which was available, say for example, this was the earlier surface which was available at the end of the LST. So, this surface is now partially eroded along this zone by wave erosions, wave activities. So, the surface which is forming over here, this surface is the wave ravinement surface formed by wave reworking processes. So, the river system is supplying the sediments which are forming this estuary over here. However, that is a backstepping system, that is a retrograding system. So, the river aggradation will be going on over here, followed by the formation of estuary deposits over here. So, we get a prism formed in this part, where the initial part is the fluvial part followed by the estuary part. And at the top of this estuary, we can get the formation of the barrier bars or the barrier beach system. The wave refinement processes will be confined in this zone, whereas the tidal refinement processes will be confined within the estuary towards the landward direction, little bit inside the estuary. Now, due to this process going on over here, what are the major system that we are developing over here? Number one, fluvial system, they are showing aggradation and they are showing onlapping pattern. So, the river systems will be dominantly meandering river with the development of some say crevasses plate deposits, very well developed overbank areas, very well developed channel and point bar systems. So, all these things will be there. Number two will be the formation of estuary. So, the first point was fluvial onlap. So, these two together will be overlain by or onlapped by the backstepping beach system or barrier bar system, which will be occupying these areas. They will be associated with abundant wave refinement process. So, formation of good wave refinement surfaces, and this wave refinement process, which is very close to the self edge, as you can see from here at this particular phase, this will lead to instability in the self edge area. So, instability in the self edge. So, this instability will lead to formation of or reworking of the sediments which are supplied by the river as well as developed from this zone by this erosional process of the wave refinement process. And those sediments associated with water, they will come down the slope forming this kind of levied channels, and they will flow much inside, much away within the basin floor, and finally they will form this kind of splay type deposits. So, there will be successive such levied channels will be forming, and they will be coming over here and they will be distributed like this. So, successive levied channels, and what will be the nature of the deposits? These are low density turbidites, low density sandy turbidites, they will be coming over here. So, the number 6 is formation of these low density turbidites through levied channels. And when this process is going on, so this zone, this area is apparently is devoid of any sediments. So, in this part what we expect? Deposition of, say here the water level is significantly high. So, from here gradually the fine grain sediments which are available in suspension, they will start getting deposited. So, they will form this kind of deposits over here in this particular zone. So, this area will be covered up by this kind of sediments, dominantly by fine grain sediments deposited from suspension. So, these sediments forming or occupying the slope area, covering up the slope area and gradually onlapping the slope area, they are called as the hilling phase deposits. So, we will get formation of this kind of hilling phase deposits along the slope area, which will start onlapping. So, during the early phase of TST, what we are expecting? This much of variations. We are getting a transgressive prism which is commonly created by aggradation of the fluvial system, onlap of the fluvial system, formation of estuary, backstepping of the estuary system, and backstepping of the barrier beach system. We will get wave refinement process, we will get instability along the self edge, we will get formation of hilling phase deposits, we will get deposits in terms of low density turbidites which will be formed through long levied channels depositing the low density turbidites away from the self area within the deep basinal part. So many processes that can occur that will take place during the early phase of TST. So, this accumulation of the shallow marine facies in a transgressive setting is commonly governed by, commonly controlled by several factors. So, the first one is the limited sediment supply. during the shoreline transgression, because during this phase most of the riverborne sediments are trapped within the rapidly aggregating fluvial systems as well as the backstepping coastal systems. And the second point, second reason is that additional source of sediments is commonly provided by the process of wave erosion in the upper surface area. So, that supplies the main sediments for accumulating in the shallow marine part in the form of macroforms. So, the wave refinement processes, they erode the underlying normal regressive self edge deltas, and also they can erode the open shoreline systems, and they continue to supply sand for the deep water turbidity flows. At this early phase of TST, this wave refinement process is very close to the self edge, very near to the self edge, and that actually helps in supplying sand for the turbidity flows. So, commonly we get successive deep water turbidity flows in response to these wave refinement processes going on in the shallower part. So, these turbidity flows tend to be of low density type, similar to the turbidity currents that we have seen, that we have discussed in case of low stand systems tract, the LST. There also we have seen that this kind of low density turbidity flows develop. Exactly similar kind of turbidity flows will develop, and exactly similar type of turbidites will be forming in the deep basinal part. Such low density turbidity currents are commonly underloaded. Now, what is this underloaded? What is the meaning of this underloaded? That means the energy of the flow is relatively higher with respect to the sediment available. So, the sediment load is less in this kind of flow. So, they have relatively higher energy, higher strength, and they flow with higher velocity. So, due to that higher energy, due to that higher velocity, this kind of currents commonly entrench through the float. When they are going down the slope, they commonly entrench, and as soon as they reach the flat surface at the basin floor where the gradient is very low, they become overloaded. And as soon as they become overloaded, now what is this meaning of overloaded? That means the energy is drastically reduced. So, now that balance energy more than sediment load is just reversed, and now the sediment load is more with respect to the energy available. So, we call that one as overloaded condition. So, now as it is overloaded, so we get aggradation of these turbidites, turbidity currents, forming aggradational pattern on the basin floor. The LST and the early TST turbidity flows, both are low density turbidity flows, travel further into the basin with respect to the high density late FSST flows, late falling stage flows, because the higher proportion of mud sustains the construction of levees over larger distances, and that helps the flow to continue for long distances remaining within the channel. As soon as they will splay over, as soon as they will spread over, their fluidity will be less. But in this kind of condition, during this LST and early TST, turbidity currents, they remain restricted within the channels, and that results in large distance flow of this kind of turbidity currents. What happens during the late TST phase in the same basin? The conditions are relatively different. So, during the late TST phase, what we can expect? Again, we can have a simple diagram. Say for example, this is the continental side where a fluvial system is reaching over here, and during this late TST, when the sea level is much higher and the sea is trying to retrograde at much higher rate. So, we get a very well developed estuary system at the river mouth area, very well developed estuary system, and that estuary system may be associated with some barrier bars which may be backstepping. The entire estuary system is also backstepping, and this results in the formation of a transgressive prism, again a continuation of the early TST phase. So, where we get a transition from fluvial to estuary system, and this estuary system will be further onlapped or further retrograded by this beach system which are also backstepping. So, over here again we will get the wave refinement processes going on along this area where wave reworking is going on, forming the wave refinement surface. But now, since it is the late phase of TST, so we are looking at this part of the curve now, the late phase of the TST. If this is the entire TST, within that we are looking at this part now. So, now the shoreline has retreated back significantly, and this has led to opening up of abandonment of the self area. Earlier, during the early phase of TST, this self area was not exposed, was not available, because at that time this wave refinement process, formation of estuary, all these were going on very close to, very near to the self edge area. So, now we have this self area available, and then we have the self break and the depressional part. So, the majority of the sediments which are coming from this direction through the fluvial system, they are getting trapped over here. They are getting trapped within the estuary, they are getting trapped within the fluvial systems which are aggregating and onlapping, they are getting trapped in the backstepping beach system. So, a very low amount of sediment may be available and they may get supplied by this wave refinement process. So, some sediments from this area may get eroded by this wave refinement process and they can get supplied along this direction. So, when sediments are supplied towards the self, now what can be the processes which are responsible for that supply? Dominantly storms, that means the high energy waves, or some tidal currents. And in response to that tidal current or storm activities, we can get deposition of this kind of sand bodies, which are nothing but the formation of the sand microforms produced on the self. So, this kind of detached sand bodies which are significantly large enough that can form within the self area during this late phase of TST, as the self is now exposed and sediment is supplied by storm or tidal currents. In rest part of the self, it is a very low energy condition, it is abundant condition. However, the water level is significantly high, water level is going on at this level. So, this entire area gets very fine grained deposits forming a condensed sections. So, in rest of the part of the self, we expect formation of a condensed section. Now, this much of water depth or this sudden change in the water depth and this kind of encroachment leads to hydraulic instability over here in this zone, and that leads to development of successive debris flow which will be developing from here, from this zone, and they will be coming down this area and they will be deposited in this area. Now, since these are debris flow, what are the materials available? The mud which is available under these condensed sections, they are the source materials now. So, dominantly we get mud flows to come down over here and getting deposited in this area. So, initially a canyon will be formed, or maybe some earlier present canyons, they will be occupied by these mud flows like this. The next one will be covering up the next phase of the canyon, and in that way the successive mud flows will try to cover up, try to retrograde also. So, in that way they also form a part of the healing phase deposit, they also form a backfilling of the canyon system. Apart from these mud flows which are occurring or generating from this self edge area, the rest of the portion of the slope area and the depressional part is going through a very low energy condition, a very calm and quiet condition, where continuously fine grained sediments are getting deposited. So, due to that deposition, again we will get formation of the healing phase deposits or the transgressive slope apparence formed over here in this part, in this area. So, what are the deposits, what are the processes and conditions going on? in the late phase of TST. So, number 1 is fluvial onlap, number 2 well developed estuary, number 3 well developed backstepping beach system, we can have wave ravagement surfaces which may form over here. So, these 3 together will form the transgressive prism which will be formed, which will be present during this late phase of TST. Now, apart from these areas, these processes and the resultant products which are confined into the marginal marine area, now we will get deposition into the shallow marine area in the form of self macroforms, and along with self macroforms we can also get the condensed sections. So, these are the deposits that will form in the shallow marine area. Now, this is also resulting in instability in the self edge, instability in the self slope break, and that will lead to formation of, so that is point number 7, the formation of high density debris flow deposits or successive mud flow deposits, which are also showing a kind of backfilling pattern, backfilling of the canyons. And finally, number 8 associated with all these is the healing phase deposits. So, during the late phase of TST, we are getting 8 significant deposits or products in terms of sedimentation, and each of them are characterized in terms of distinct processes going on in different areas, starting from the fluvial to marginal marine to shallow marine to deep basinal part. Now, here comes this particular term that I have used so many times during these last 2 diagrams. This is a healing phase deposit. This healing phase deposit is a very typical one, very characteristic one for transgressive systems tract, because this we will not get, we cannot observe in any other kind of scenario. So, commonly we get them in the form of a wedge, and these are typical kind of infill pattern, as like it is healing over the gap or the damage that has been done during the falling stage, during the lowering of the base level, and they try to re-establish or reframe the bathymetric profile, whatever damage was done at the end of the regression. That is why the term used is healing phase deposits. So, healing phase deposits or healing phase wedges, they may form in various settings in the transgressive marine environment, and in each of these settings it commonly involves similar depositional processes. So, what are the areas where we can get these healing phase wedges? We can get them in the shore face area, but in the shore face area where the overall water depth is significantly low, and also the amount of damage, the erosion caused, the slope break, the slope change is significantly low in respect of the depth. So, the wedge thickness is also significantly low in case of shore face, commonly ranges in terms of meters. We can get similar healing phase wedges in the self area where thickness may be little bit more, maybe up to tens of meters, and commonly they fill up the low area which are kind of the outboard of the youngest regressive clinoforms. And the dominant one, dominant healing phase deposit that we get in the deep water environment, where the wedge thickness can reach up to hundreds of meters, and that tries to smooth out the difference in the gradients between the continental slope and the basin slope. So, healing phase deposits, they are again very characteristic. So, if I draw the self area, say for example, this is the self area, and this self area which is exposed after the low stand phase or maybe after the early phase of transgressive systems tract. So, below this we can expect the clinoforms which have been formed during the LST, the clinoforms of the LST delta. So, on that the self area is exposed, and then we get this break, the last clinoform of this delta system. After this LST phase, when the sea level is rising from this particular level, it is rising up. Due to this rise in the self area, we can get this kind of sand ridges, and also we get the condensed sections. So, this is the condensed section forming in major part of the self, and this kind of sand ridges or the sand macroforms. Now, when we are getting this slope break, say for example, this is the slope break and this is the depressional floor. So, in this area we get these healing phase deposit forming wedge like structure, and how they get deposited? The first wedge forms like this, like it is onlapping over here. The second wedge forms like this, the third one like this, the fourth one like this, and it goes on like this one. So, successive deposits, successive units, clinoforms, they will be onlapping one after another, and finally at the end of the transgression we get a smooth surface which is decreasing this gap in the gradient, gap in the slope, gap in the height with respect to the self and slope break. So, onlapping healing phase wedges are diagnostic for transgressive systems tract. So, this kind of deposits onlapping into the slope area, we will call them as the transgressive slope aprons. Transgressive slope aprons. This particular term was first time used by Galloway in 1989. Now, looking into the self sand deposits, already we have discussed about these self sand deposits little bit in our previous lecture. So, these are commonly recognized as another significant shallow water component of transgressive systems tract, because we do not get such sand deposits, large scale sand deposits in the self except the TST phase. In any other condition base level changes, we do not expect formation of such self sand deposits. So, formation of this kind of self sand deposits is favored during the transgression when a significant portion of the continental shelf is submerged and it is undergoing, it is affected by certain processes like storms and tides. So, subsequent aggradation during the next HST, as we know that TST will be followed by an HST normally. So, that HST where we have already seen that in the entire self area during HST we get deposition of fine grained sediments forming condensed sections. So, that actually helps, that aggradation pattern actually helps in preservation of these self macroforms, these self sand bodies. So, commonly as the TST is followed by HST, these self sand bodies have high preservation potential. No other systems tracts offers the formation and preservation of such sand rich macroforms in the self area. So, self sand bodies in the form of sheet like sand bodies, in the form of ridge like sand bodies, in the form of ribbon like sand bodies, they are very much characteristics of transgressive systems tract. So, if I want to conclude over here in terms of what are the overall depositional pattern, what are the overall depositional products, and what are the characteristic features of the TST deposit. Based on our discussion on last 3 lectures on the transgressive systems tracts, what we have seen that there will be onlap of the fluvial system, and that onlapping of the fluvial system will lead to aggradation of the fluvial system. So, the channel systems will be filled up, there will be more overbank deposits with respect to channel amalgamation. The channel forms will be very frequently affected by tidal currents. The fluvial forms or fluvial system will be retrograded or onlapped by the estuarine system, which will form in the mouth bar area, in the coastal area, and that estuary system, its condition also may vary depending on the relative sedimentation rate at the river mouth area and the rate of transgression occurring along the shoreline, and accordingly we can get a proper delta forming somewhere, or a retrograding shoreline associated with the Bayhead delta, or a retrograding shoreline with an estuary. So, whatever be the position, finally it will be again onlapped by the shore conditions, the shore sediments, which are commonly represented by the beach sediments, and they are commonly associated with some ravinement processes, which is again characteristic of transgressive condition. So, commonly wave ravinement process and tide ravinement processes. Now, these wave ravinement processes, they will further transport sand into the shallow marine part, forming large sand macroforms, sand ridges, sand seats, which are characteristically formed in the shelf area under the influence of storm or tide, and they are characteristically found in the transgressive systems tract only. In rest of the part of the shelf area during TST, we commonly get condensed sections. When we come over to the deep basinal part, during the early TST phase, we get supply of low density turbidites, which form part of the submarine fan, whereas in the late phase of the TST, we commonly get mud depositions in the form of successive mud flows due to instability, due to hydraulic disturbances in the shelf edge area. And along with all these deposits, also we get very special type of deposit called as healing phase deposit, which tries to cover up all the topographic break that has formed due to the falling of the base level or due to the accumulation of clinoforms in more steeper way during the forced regressive phase or during the normal regressive phases. So, that healing phase deposits, which are again a characteristic feature of the transgression found within TST, can be found in the shore area, can be found in the shelf area, and most prominently they are found in the deep basinal part in the form of transgressive slope apron. So, when we are getting so much of variations in terms of depositional conditions, in terms of depositional products, in terms of facies architecture, so definitely we can expect different conditions with respect to its economic potential, with respect to accumulation of hydrocarbon, accumulation of other resources like coal or placers. So, we will continue this discussion in our next class, and there we will try to understand about those aspects in terms of the economic potential of the TST deposits. These are some of the references for your further study. Thank you everyone.